In Lesson 10.2, Part 1, you will use combinations. A combination is an unordered grouping. The number of combinations of R objects taken from a group of n distinct objects is given by this formula. N choose R is equal to n factorial divided by n minus R factorial times R factorial. In example 1, we're using a deck of 52 cards. And in A, we want to know how many different 7-card hands are possible. So we'll write a combination because we want to take 7 cards from 52, so that's 52 choose 7, or that combination is 52 factorial divided by 52 take away 7 factorial, 7 factorial. 52 factorial over 52 take away 7 is 45 factorial, 7 factorial. And now we'll expand. In the numerator we have 52 times 51 times 50 times 49 times 48 times 47 times 46. And at 45 I'm going to stop. I'll have 45 factorial because in the denominator I also have 45 factorial, and I'll be able to cancel all those factors top and bottom at once. In the denominator I also have 7 factorial, so I'll expand that. 7 times 6 times 5 times 4 times 3 times 2 times 1. And now we'll cancel those like factors top and bottom to simplify. 45 factorial is canceled. 7 goes into 49 7 times. And 6 times 4 is 24. We can cancel that with 48. 24 goes into 48 twice. Okay, and then I have 5 times 2 is 10. 10 goes into 50 5 times. And I have this factor of 3 yet. That 3 goes into 51 17 times. So now multiplying the factors that are left in the numerator, we're going to find that we have 133,784,560 possible 7-card hands from that deck of 52 cards. That's quite a few. Okay, in B it says how many of these hands have all 7 cards of the same suit. So here we need to first choose one suit from 4. So that's 4, choose 1. And whenever we say and in these combination problems, we're going to find that we're going to multiply. If we say or, we're going to add. So in this case, we're multiplying. And after I choose one suit from 4, now I need to choose 7 cards from those 13 cards in that suit. So 13 choose 7. And now let's write those combinations. 4 factorial over 4 take away 1, which is 3 factorial, 1 factorial, times 13 factorial over 13 take away 7, that's 6 factorial, 7 factorial. Okay, and expanding, we have 4 times 3 factorial. Stop there because I have 3 factorial in the denominator. 1 factorial is just 1. Okay, in the second combination, I have 13 times 12 times 11 times 10 times 9 times 8 times 7 factorial, which will cancel with the 7 factorial in the denominator. But I'll expand the 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. Okay, and now canceling, let's get rid of that 7 factorial top and bottom. Let's get rid of a factor of 12. We have 6 times 2 in the denominator and 12 in the numerator. Let's get rid of a factor of 5. That goes into 10 twice. And 4 goes into 8 twice. And 3 goes into 9 3 times. Okay, and then in the first combination, get rid of the 3 factorial top and bottom. And now multiplying all of those factors that are left in the numerator, we'll find that we have 6,864 hands possible. So that's how many hands are possible when 7 cards are of the same suit. In example 2, on vacation you can visit as many as 5 different cities and 7 different attractions. In A, you want to visit exactly 3 different cities and 4 different attractions. How many different trips are possible? So in this combination problem, we want to choose 3 cities from 5 cities. That's 5, choose 3. And so we're multiplying, and we want to choose 4 attractions from 7. So that's 7, choose 4. Let's write those combinations. 5 factorial over 5 take away 3, 2 factorial, 3 factorial, and 7 factorial over 7 take away 4, which is 3 factorial, 4 factorial. Okay, and now we'll expand. So we have 5 times 4 times 3 factorial in the numerator of the first combination. We have 3 factorial in the denominator. We also have 2 factorial, which is 2 times 1. Okay, in the second combination, we have 7 times 6 times 5 times 4 factorial. I'll stop there again because I have 4 factorial in the denominator. I also have 3 factorial, which is 3 times 2 times 1. Okay, so let's cancel to simplify. Cancel 4 factorial top and bottom, and cancel a factor of 6 top and bottom. In the first combination, we'll cancel that 3 factorial top and bottom and our factor of 2. So now multiplying across, how many different trips are possible? 350 is the product that we get. So 350 trips are possible when you visit 3 cities and 4 attractions. Okay, in B, suppose you want to visit at least 8 locations. How many different types of trips are possible? Well, if we're going to visit at least 8, we could visit 8, or we could visit 9, or we could visit 10, or 11, or all 12, because there's 5 cities and 7 attractions. That's a total of 12 possible locations. So we would have to consider all of those possibilities. We could choose 8 from 12, or, which means we're going to add when we say or we could choose 9 from 12 and still satisfy that condition of at least 8 locations, or we could choose 10 from 12, we could choose 11 from 12, we could choose all 12 locations for our trip. So we need to write all of these combinations. So let's start with 12 choose 8. That's 12 factorial over 12 take away 8, which is 4 factorial, 8 factorial, plus 12 factorial over 12 take away 9. That's 3 factorial, 9 factorial, plus 12 factorial over 12 take away 10, which is 2 factorial, 10 factorial. Okay, our fourth term, 12 factorial over 12 take away 11, which is 1 factorial, 11 factorial. And the last term, 12 factorial over 12 take away 12, which is 0 factorial, 12 factorial. Okay, and now we need to expand. So in our first term, we have 12 times 11 times 10 times 9 times 8 factorial in the numerator. In the denominator, I have 8 factorial, and I have 4 factorial, which is 4 times 3 times 2 times 1. Okay, in the second term, 12 times 11 times 10 times 9 factorial over that 9 factorial. And 3 factorial is 3 times 2 times 1. Okay, third term, 12 times 11 times 10 factorial divided by 10 factorial and 2 factorial. 2 times 1. Next we have 12 factorial, 12 times 11 factorial over 11 factorial, and 1 factorial is 1. Okay, and then the last term is 12 factorial over 12 factorial, and 0 factorial, remember, is defined to be 1, and that's exactly why, so that we can have a value for 0 factorial in these combinations. Okay, and now going back and canceling, let's cancel 8 factorial top and bottom. Let's cancel a factor of 12 top and bottom, and 2 goes into 10 5 times. Okay, in the next term, cancel that 9 factorial top and bottom, and 6 goes into 12 twice. Okay, then we can cancel 10 factorial top and bottom. 2 goes into 12 6 times. We can cancel 11 factorial top and bottom, and in the last term, 12 factorial top and bottom. So going back and getting these products, we'll find that the first product is 11 times 5 times 9, 495. And the second product is 2 times 11 times 10, so 220. The third product is 6 times 11, so 66. The fourth product is 12, and the last product is 1. So when we add all of these terms together, we find out there are 794 trips possible. And remember, the restriction was that we visit at least 8 locations. Include with your notes of this video guided practice problems 1 through 5 on page 691 of your textbook.